Hello everyone, in this video we will learn all about related rates. To start, solve the derivatives of the following. What is the derivative of 4x to the power of 3? The result here is 12x squared, derivative of x with respect to x. So in this case, we can cancel dx. So that would become 12x squared. Another, find the derivative of 2r to the power 4 with respect to x. In this case, the result is 8r to the power of 3 times dr dx. Another, find the derivative of 3s to the power of 5 with respect to y. In this case, the result is 15s to the power 4 times ds dy. Another, find the derivative of x to the power 5 with respect to t. The result here is 5x to the power 4 times dx dt. Another, derivative of y to the power of 8 with respect to t. The answer here is 8 to the y to the power of 7 times dy dt. Now take note, all of these examples are related in the concept of related rates. So when you say related rates, it is a set of problems that concerns on the relationship among the rates of change of several variables with respect to time. So if you're given dy over dt, so it means the rate of change in y with respect to t or time. Another, if you're given dx over dt, this is the rate of change in x with respect to time. Now, let's consider this one. If z squared is equal to x squared plus y squared, dx over dt is equal to 4, and dy over dt is equal to 5, find dz over dt when x is equal to 8 and y is equal to 15. Now in this case, considering the equation x squared plus y squared is equal to z squared. Now take note, x and y are given, so let's substitute that. So 8 squared plus 15 squared is equal to z squared. So adding this two, that would become 289. Getting the square root to both sides, the value for z here is 17. Now again, making use of the original equation, let's get the derivative of this. Derivative of x squared is 2x dx dt, derivative of y squared is 2y dy dt, and the derivative of z squared is 2z dz dt. Now at this point, we will substitute. Now take note, the value for x here is 8, dx dt here is 4, the value for y is 15, and dy dt is 5. Now we solve the value for z as 17, and we are solving for the rate dz over dt. Now simplifying this one, you add this two, that would result to 214. Dividing both sides by 34, so that would become 214 over 34, or dz over dt is approximately 6.29. Now take note, there are steps in solving problems that involves related rates. Number 1, as much as possible, illustrate the problem. Number 2, identify the given and what's required. Now remember that if a quantity decreases over time, then its rate of change is negative. Another, solve for missing quantities, solve the derivatives, then substitute, and of course, solve the desired related rates. So let's have the first problem. The radius of a circle is decreasing at a rate of 3 centimeter per minute. How fast is the area and circumference of the circle changing when the radius is 6 centimeters? Now take note, the radius here is 6 centimeters. Another given is 3 centimeters per minute. So that is the rate in change of the radius. So that's why it's dr over dt, the change in the radius with respect to time. Now take note, how come it is negative? It is negative because over time, the radius will decrease. Now what is asked here is the change in the area and the change of the circumference with respect to time. Now take note, of course, this is the circle where the radius r, or 6. The formula for area is pi r squared. Now getting the derivative to both sides, so this will become dA over dt. Derivative of pi r squared is 2 pi r that would be dr over dt. Now at this point, let's substitute. So 2r, so twice of 6, so that would become 12. Then you have your pi. dr dt here is negative 3. So simplifying this, so the change in the area with respect to time is negative 36 pi centimeters squared per minute. Okay, another. The formula for circumference is 2 pi r. Now take note, the derivative to both sides, so this would become dc over dt. Derivative of 2 pi r is 2 pi, then dr dt. Now at this point, let's substitute. So 2 pi dr dt is negative 3, so simplifying, the change in the circumference with respect to time is negative 6 pi centimeters per minute. Okay, another example. A spherical balloon is being inflated at the rate of 350 centimeter cube per minute. How fast is the radius of the balloon increasing when the radius is 5 centimeters? Now take note here, we have the first given, 350 centimeter cube per minute, and that is the change in the volume of the sphere with respect to time. So that will be positive because it is increasing over time. Okay, another given here is the radius of the balloon, which is 5 centimeters. Now, what is asked here is the rate of change in the radius with respect to time. Now, take note, the formula for volume of a sphere is V is equal to 4/3 pi r cubed. Now, using this formula, let's get its derivative. Derivative here is dv over dt, 4/3 pi r cubed. So, multiply, cancel 3. So, that would become 4 pi r squared dr dt. Now, at this point, let's substitute. dv dt is 350. 4 pi, our r here is 5 squared dr dt. 5 squared, that's 25 times 4. So, that would become 100 pi. Now, simplifying both sides, so our dr dt here is approximately 1.1 centimeters per minute. So, therefore, the radius of the balloon is increasing at the rate of 1.1114 centimeters per minute. Okay, another example. A 10-meter ladder is leaning against a wall. If the bottom of the ladder is being pushed horizontally towards the wall at 2 meters per second, how fast is the top of the ladder moving when the bottom is 6 meters from the wall? Now, illustrating the given situation, we have this. We have the wall, then of course we have the ground. This is the ladder and it is 10 meters long. Now take note, the bottom of the ladder is being pushed towards the wall and the rate here is 2 meters per second. So take note here, it is negative because eventually when you keep on pushing the bottom of the ladder, its distance from the wall will get smaller and smaller. Now again, if you push the bottom of the wall towards the wall, the top of the ladder will also move up. So take note, another given here is 6 meters. That's the distance of the foot of the ladder from the wall. Okay, so these are the given. So eventually, you are forming a right triangle here. So 10 here is the hypotenuse. The base is 6. Y, or the height here, is unknown, and another unknown here is dy dt, the change in height of the top of the ladder. Now, making use of the right triangle equation, which is the Pythagorean theorem that you can form, which is x squared plus y squared equals 100. So, substitute x as 6, so y squared is 100 minus 36 or 64. Get its roots, the value for y is 8. Now take note, making use of this original equation, let's get its derivative. So derivative of x squared, 2x dx dt, derivative of y squared is 2y dy dt, and derivative of 100 is 0. Now at this point, let's substitute. The value for x is 6, our dx dt is negative 2, and the value for y is 8, and dy dt is unknown. Multiplying this is negative 24. Transfer to the other side, that would become 24. So simplifying further, dy dt here is 3 over 2, or the top of the ladder is moving at the rate of 1.5 meters per second. So take note, dx dt is negative because eventually its distance from the wall will decrease, while dy dt is positive because eventually over time its height is increasing. Okay, another example. A 12-meter ladder is leaning against the wall of a building. So this is the ladder. The bottom of the ladder is sliding away from the wall at the rate of 1.5 meters per second. So at this point, this is dx over dt. And take note, this is positive because eventually if this keep on sliding away from the wall, its distance from this wall will increase over time. Now, how fast is the top of the ladder sliding down when it is 3 meters above the ground? So the height here is 3 meters. So what is asked? So if the bottom is sliding away from the wall, the top of the ladder is sliding down towards the ground. Okay, so the base here is unknown. Still, we are forming a right triangle. So our y is 3, dx dt is 1.5, hypotenuse is 12, x is unknown, and dy dt is also unknown. Now, making use of the right triangle, we can form this equation, x squared plus y squared equals 144. Now, in this case, the value for y is 3. So, 144 minus 9, that's square root of 135. And that's the value for x. Okay, now, still making use of the original equation, let's get its derivative. Derivative of x squared is 2x dx dt. Derivative of y squared is 2y dy dt. And derivative of 144 is 0. At this point, let's substitute. The value for x is square root of 135. Dx dt here is 1.5. The value for y is 3. And dy dt is unknown. Now, simplifying this, multiply, so this would become 3 square root of 135. Transfer to the other side, that would become negative 3 square root of 135. Dividing both sides by 6, so eventually dy dt here is negative 5.81 meters per second. So the top of the ladder is sliding down with that rate. Okay. Okay, another example. A street light is mounted on a pole 24 feet tall. A man, 6 feet tall, walks away from the pole at a rate of 4 feet per second. So how the length of his shadow is changing at this instant, and how fast is the tip of his shadow moving? So take note, we have here a pole that's 24 feet tall. We have here a 6 feet tall man, and he is moving away from the pole at this rate. So take note, it is positive because over time its distance from the pole will increase. Okay, so let's assign variables here. So from the foot of the lamp to the man, let's have that as x. From the man going to this end, it's s. So we'll have this as L. So take note, we're forming still a right triangle here. Now, getting the triangle diagram, we will get this. 24, 6, X, L, and S. Now, at this point, we can form our proportion, in which we can have 6 over 6 is equal to 24 over X plus S. So, cross-multiplying this, we will get 6S plus 6x is equal to 24s. Combining like terms, so the value for s here is x over 3. Now at this point, let's get its derivative to both sides. So this is ds over dt, derivative of x over 3. So that's 1/3 dx over dt. So let's substitute. Take note, our dx dt here is 4. So eventually, this would become 4/3 feet per second. So the length of his shadow is changing at 1.3 feet per second. Okay, another. Now take note here, L is actually x plus s. So getting the derivative of this, so this is dl dt, dx dt plus ds dt. Now, substituting this one, our dx dt, take note it's 4. Our ds dt is obtained as 4/3. So adding this 2, so that would become 16 over 3 feet per second. Or the tip of his shadow, so which is this one, is moving at 5.3 feet per second. Okay, another example. An automobile traveling at a rate of 20 meters per second is approaching an intersection. When the automobile is 100 meters from the intersection, a truck traveling at a rate of 40 meters per second crosses the intersection. The automobile and the truck are on perpendicular roads. How fast is the distance between the truck and the automobile changing 2 seconds after the truck leaves the intersection? Now, take note of this given. So, the rate of the speed of the car is 20 meters per second. So, it is negative here because over time, its distance from the intersection will decrease. While the rate of speed for the truck is positive because over time, its distance from the intersection will increase. So take note of this given. So we have here x, y, and z. So we're still forming a right triangle. Now to find the values for x, y, and z, so that's distance. So take note the formula for distance is rate times time. So for the distance of the car, so take note this is after 2 minutes or 2 seconds. So for the rate of the car, so that's 20. Times 2, that would become 40. So take note, since you started from 100, when you approach the intersection, this will decrease. So that would become 100 minus 40, so therefore it is 60 meters. While the distance covered by the truck, so take note its speed is 40. So 40 times 2 seconds, so that's 80. So their y here is 80. So take note, we're forming a right triangle. So x squared plus y squared equals z squared. So substituting here, so our x is 60, our y is 80, so 60 squared plus 80 squared. So eventually the value for z here is 100. Now making use of the original equation, so x squared plus y squared equals z squared. Getting the derivative of this, so derivative of x squared is 2x dx dt plus the derivative of y squared is 2y dy dt, and the derivative of z squared is 2z dz dt. Now at this point, we can divide the entire equation by 2, so it will become like this. So let's substitute. The value for x is 60, dx dt is negative 20, the value for y is 80, and dy dt here is 40. The value for z is 100, so we're solving for dz dt. So simplifying this one, eventually we will end up with 20. So therefore, the distance between the truck and the automobile increases at the rate of 20 meters per second. Water is pouring into an inverted cone at the rate of 8 cubic meters per minute. If the height of the cone is 12 meters, and the radius of its base is 6 meters, how fast is the water level rising when the water is 4 meter deep? So take note, this is the illustration. So the given here, which are not in the figure, so we have here 8 cubic meters per minute. So that's dv dt, that's the change in the volume with respect to time. So it is positive because over time it will increase. Then another is the height here, which is 4 meters. Now take note, in this illustration, we can get its triangle diagram. So in which it looks like this one. So this is the base, which is 6 meters. So parallel to that, we have here as a radius at the lower part, which is r. The height here is h. And of course, the height of the cone is 12. Now, making use of the proportions, we can have this r over h is equal to 6 over 12. Now, 6 over 12, that's actually 1 over 2. So our r here is actually h over 2. Now, take note, formula for volume of a cone is V is equal to pi over 3 r squared times the height. Now, take note, we still have two variables here, so we need to substitute further. So take note, r squared, we can replace that as h over 2 squared. So simplifying this one, this would become h cubed. Then 2 squared, that's 4 times 3, so that would become 12. So at this point, we can get its derivative. So derivative of v, that's dv dt. Derivative here, so 3 times 12, so that's 1/4. So h3, so that will become h2 dh dt. So at this point, we can substitute. Take note, our dv dt here is 8. Our height here, it's given here as 4. So 4 squared dh dt. So simplifying further, 4 squared, that would become 16 divided by 4, so it's 4 pi. Dividing both sides by 4 pi, so eventually we will end up with 8 over pi. Or dh dt, the change in the height with respect to time, if the height is 4 meter dip, is 0.63 meter cube per minute. So that's how the water level rises when the water is 4 meter dip. Okay, another example. A plastic container in the shape of a cylinder is being filled with water at the rate of 450 pi cubic centimeters per second. If the radius of the plastic container is 20 centimeters, how fast is the height of the water rising? So take note, this is the height of the water. So given, so we have here 450 pi centimeter cube per second. So take note, it is positive because over time, its volume will increase. Okay, another here is the radius, which is 20 centimeters. Now take note, the formula for volume of a cylinder is V is equal to pi r squared times the height. Now, at this point, let's substitute. Take note, our r here is 20. So 20 squared, so that would become 400 pi h. Now at this point, let's get its derivative. So derivative is dv dt. Derivative of 400 pi h is actually 400 pi dh dt. So let's substitute here. So dv dt here is 450 pi. This is 400 pi dh dt. Dividing both sides by 400 pi, so we will end up with 9 over 8. Or the change in height with respect to time is approximately 1.1 centimeter cube per second. So that's how the water level rises. Okay. So that would be all. Thank you.